Hello everybody, today we're going to be going through the Onshape Learning course, Introduction to Part Studios exercises. So we'll go ahead and get right into it. So first exercise is the control arm. So I'm going to go ahead and make sure my workspace units are in millimeters, right? Yep. And then I'm going to go ahead and create a new part studio, and I'm going to name it control arm. Okay. Cool. So now I'm going to go ahead and create a sketch. So this is going to be on the top plane. I'm going to orient normal. Okay. And then they want us to go ahead and sketch this out. So I'm going to go ahead and start with the overall geometry I see. So I see two circles here, and then I see over here there's two circles as well, right? And there are, of course, a lot of different ways to sketch this, but then I'm going to go ahead and grab these two lines. Here I can see I can get a coincident. I can also get a tangent. Which is what I do eventually want. So I can go ahead and grab that, repeat down here as well, and then I'll add my missing tangent constraint here and here. So now we can see these create like a smooth connection, and it touches thanks to the coincident. Yeah, so that's good. This is horizontally inline, which we like as well. And then yeah, let's see. So then I can start adding dimensions. So I'm going to add this 70 millimeter one. My first dimension will scale the sketch, which is good. I see this inner circle is 35 millimeters. I see this outer circle is 35 millimeters, right? And I see this is 20 millimeters. And then I'm going to take advantage of the fact that this is symmetric to mirror this half. So I'm just going to grab this half, and then I'm going to hit mirror. And then I'm going to use my right plane as my mirror plane, so that will mirror around like that. So you can see those are connected. And of course you could also sketch it out as well, and then like add the equals constraints between like here and here, and here and here. That would also be perfectly fine. But you know, since we do have the symmetry, you may as well take advantage of that. Yeah. And then I see this overall dimension here is 200. Important to note, this is on the outside of the circles. So it's not the center points like you would normally expect. It's actually out here. And so that can be an easy mistake to make. But yeah, so that's fully constrained. And then I also have this center point rectangle. And they have us, they recommend drawing like a construction line like this here. We don't actually need it because we can just use the right plane. But you know, if you want to go ahead and draw that, that won't hurt you. And you can also use that. You know, it's not a problem. It's just a matter of preference. And you know, this way it's slightly cleaner, perhaps. But yeah. Okay, cool. Yeah. So this should be everything we need. So I'll go ahead and confirm that. Okay. So now we're going to go ahead and extrude this. So I'm going to go ahead and create my extrude, and then I can go ahead and select my faces like this. Yeah. And then I want to make sure my depth is 40 millimeters, and then I can play with my depth, my direction like this, but in this case the default direction pointing up is perfectly fine. Yeah. Cool. Alright. And so now I'm going to go ahead and create my second extrude. So I have to show my sketch again because after I create an extrude with it, it gets hidden by default. And so one thing I want to point out here, right, is Onshape has what's called editing logic when you're manipulating features. And so what that does is it can automatically set and change parameters based on what you're clicking or how you're modifying your feature, right? So here, for example, I'll point out this is a new extrude, right? And then, yeah, so this is a new extrude. But if I go ahead and click this, right, you can see Onshape changed it to an add extrude automatically, right? And then it also went ahead and populated my merge scope. So this is now, instead of being a new extrude, making a new part like this, right? We are instead getting an extrude that's adding on to our existing part. And so sometimes that behavior can be helpful, like in this case, it saves us some clicks. And other times that can be problematic because it's not what we want. So anytime you're using extrude especially, extrude likes to change itself to add automatically. But anytime you're using features, you want to be mindful that Onshape can fill out and make changes as you're editing. So you just want to make sure and double check that everything is correct. Anyway, but yeah, so then I'll go ahead and grab this face as well to complete this extrude and make sure it's 25 millimeters and the direction is correct. And so if Onshape didn't trigger the editing logic for whatever reason, right, then I would have to manually change this extrude to add. And then I would also have to probably change my focus from face and sketch regions to extrude to merge scope, and then select this part manually. So that way we're adding onto this part rather than creating a new part. Okay, cool. All right, we're happy with that. And now we're going to go ahead and rename this part. And so we're going to name it control arm. Cool. All right, and that should be that. So now we can go ahead and select it and come down here and view the surface area. And so if we go do the self-check, we can see, in fact, that our surface area is a valid answer and it is correct. Cool, so we can move right along. So next up is the reducer coupling. So once again, I'll go ahead and create a new part studio, right? And then I'll name it reducer coupling, right? And then this is supposed to be in inches, so I'll go ahead and change my workspace units to inches. And I will point out workspace units is document wide. So they're recommending creating multiple documents for this. Obviously I do a lot of exercises, so I just have one document for my ease, but you can create multiple documents. That's perfectly fine. Or do it like I'm doing it, it doesn't matter. Not a big deal either way. But yeah, name that reducer coupling, yep. Cool. And then we'll get right into it. So we're supposed to create a sketch, this time on the right plane, right? Go ahead and orient normal. And once again, we can see the origin is in the middle of our sketch, so we can go ahead and start drawing around that. So I see there's a small inner circle, a big outer circle, and then there's a construction circle. The circles are on, although I don't think we actually need that, so I'm not going to create it. But yeah, and then we can see there's 4 holes, right? And then, of course, so we can see that they're, on a hole pattern around the center. Actually, yeah, so I'll make this, I'll just add some dimensions real quick. So I'll make this 2 inches, this is 6 inches, right? And then this is going to be like here-ish, right? And this has a diameter of 5/8 of an inch, or 0.625 inches, right? So I can enter it like that. And then it is, I guess I will go ahead and make this circle. That's fine. It's not hurting anyone. Yeah, so I'll go ahead and draw that in, right? And then of course I could draw in my other 4 circles and, like make them vertically and horizontally in line with the origin, like how they're showing. That's fine. I'm going to instead, I'm actually going to use a circular pattern just to save myself a few clicks. So the way I do that is I grab my circular pattern, I choose my entity I want a circular pattern, right? And then once again, you can see I get my click to confirm, and then I can also use these manipulators to edit it, right? So if I change this, you can see I can like set an angle to it. And then if I drag all the way up, you can see it snaps to like the full pattern, so I no longer have control of the angle, which is what we're doing here, so that makes sense. And then I can also grab this and change the count. So I could add like 6 if I wanted, and here we only need 4. So once I have it all good and set, I'll go ahead and confirm, right? And then one thing you'll notice is these are blue, right? Even though they're in the right spot, which is a little strange. And so if I grab this point and I click and drag, you can see I have this degree of freedom, right? And so we can see the default center of the pattern is the origin, but it's not constrained that way. So I can drag it off, and then I can make it so by constraining it to the origin using a coincident constraint. So now it's fully constrained. Yeah, so that's maybe a little bit faster than like just sketching them all by hand. Okay, cool. Yeah, so now we're going to go ahead and extrude our flange. Since we're using the entire sketch, I can actually just use this extrude directly from the sketch dialog instead of like confirming my sketch and then creating extrude. So I'll do that. And then we can see by default, that selects my sketch for me. And so that's equivalent to clicking the sketch in the feature list. You can see here I get faces of sketch 1, which is different from like if you manually click faces, right? Like if I manually click faces, you can see I get like individual faces, right? But when I click the entire sketch, I get all of the faces all at once. And so that can be maybe a little bit more robust because if I like add faces or like delete them later, then I won't have to like reselect them or like update my selection. On the other hand, like if I'm not like using, the default options, then, I might have to manually edit it. But, it's good to know when that's available. Okay, cool. And then we want to go ahead and make our depth 0.62 inches, which is almost 5/8 of an inch, but not quite. Oh, I accidentally hit escape. That's my bad. Yeah, so I'll go ahead and do that again. But 0.62 inches. Yeah, and I'll grab it from the feature list for posterity, even though it doesn't really matter. But yeah, so we'll go ahead and confirm that. That looks good. Okay. So let's see here. Yeah, we want to make sure we're extruding out towards the right plane. So, not this way, this way. That's important. Or actually, it's not that important, I guess, but I don't know. Yeah. All right, so now we're going to go ahead and create a sketch on the front plane, right? So it's important to note we're now making a side profile, right? That's an easy step to miss, but it is important. And then, yeah, so here we're going to go ahead and create a construction line like this off of the origin, right? And then we are going to, yeah, so they show here actually using the center of the circle, right? And so what the use constraint does is it essentially projects external geometry into your sketch, right? And like adds it as a sketch entity. So here, if I use this, right, the center, I get a line which aligns with that circle in my sketch, right? And so, obviously, an alternative is to just like create the entity manually and then like add it yourself. So here I would have to use actually the Pierce constraint, which is a little bit one of the more esoteric ones. But that basically computes the intersection of the entity and the sketch. So you can kind of think of it like as a coincident, except instead of it's for stuff that like is passing through the sketch instead of like yeah, it's for stuff that's passing through the sketch. So like I could like add it like this manually, right? And this is of course equivalent to using this edge directly, right? So two alternatives. Doesn't really matter either way. But yes, that's how we get this line, right? And so once we have that line, then we can go ahead and sketch the rest of our stuff. And then one thing you want to be careful of here is this is kind of like a slanted rectangle. So like you could use like an aligned rectangle here, for example, something like this. But you do have to note that it is slanted, so it's actually more of a parallelogram. So this has to be vertically in line like this, right? So we want like this to be in line with this edge, for example. And so if you were using a line, you'd probably have to get rid of like this perpendicular constraint. So go ahead and convert this into a proper parallelogram, right? Because with that perpendicular, you can only do like a right angle like this, which is obviously not correct. Yeah, so we'll delete that, make it a parallelogram, right? And then you could also, of course, manually sketch a box and add the parallel constraints. That would also be perfectly fine. You can see we get two parallel constraints here and there with the aligned rectangle. Yeah. Okay, so we'll go ahead and dimension this up. So this is 4.625 like this, right? And then this diameter here. So here what they're taking advantage of is the fact that if you dimension off of a construction line, so this doesn't work if you use like a plane, which is kind of curious. But if you dimension off of a construction line, right, you can't actually grab the diameter constraint. So here you can see I get my regular dimension, but if I bring my mouse down here, you can see the diameter symbol is appearing, and it's dimensioning double. So I'm like dimensioning like a rotation. which is kind of cool. You could also, of course, just dimension, you know, like this, and then do like 2.625 divided by 2. That would also be perfectly valid. But you know, this way it's a little more accurately capturing what we're trying to do here. And so that's also what they're doing over here. And so that's why in this sketch, but that only works if you're dimensioning to a construction line specifically. So that's something that's good to note. And then I'll just tie up this loose end here by just making it like vertically in line. Seems fine to me. So that way everything is nice and fully constrained. Although that part is less important, but you know, it's nice. Okay, cool. So this looks good, so I'll go ahead and confirm that. And now we can go ahead and revolve this, right? And once again, I'll point out, right, so if this part were to be hidden, right, so if I hide it, then when I go ahead and create my revolve, right, I'll just get a new part, right? So then I would have to manually change it to add, and I would have to manually, when I click add, it changed to, it focused my merge scope automatically, but I would have to manually select my merge scope like that. And so, but you know, if I do have this part shown, right, so I cancel out of that. If I do have it shown, right, then when I go ahead and create this revolve and select my revolve axis like so, right, then Onshape will use editing logic to change it to add and select my merge scope automatically. So you can see, you know, Onshape automating your life a little bit, perhaps. But yeah, it's always good to pay attention to that behavior and just be aware of when it's happening, so you know, it doesn't catch you out when and doesn't do something you don't want it to. Okay, so now we're going to go ahead and sketch on this face, which is fine. And then they want us to go ahead and use this inner circle, which makes sense. And of course, we could also, instead of so when we use it, right, you can see it's adding it to our sketch, right? So now we have a, if I hide this part, right, you can see I'm getting that sketch line. And of course, I could also just create a circle and then make it coincident with this, right? And that would also be equivalent. So either way it works, doesn't matter. And then we'll go ahead and sketch the rest of this. So again, we have a big circle, and then we have our hole pattern circle, which is a construction, right? Our big circle was 7.5, and then this is 6, right? We'll grab our bowl hole here, right? And if I want to be fancy, I guess is the hole size the same? No, it's different. Okay. So if I wanted to be fancy and the hole size was the same, I could show my sketch, right? And I could actually go ahead and make this equal to this, right? And that would make this also 0.625, you can see. But because it's different, that doesn't work. But that is kind of cute, just pointing out that you can, in fact, use other sketches like they're in your current sketch, kind of. So like it doesn't matter that this isn't in our sketch, we can still make it equal, which is kind of cool. And you could also like make equal to like this edge, for example, as well. That would also work. It doesn't have to be like a sketch entity specifically. But that is something that you can kind of think about. Although generally like making external references can be kind of problematic. Or you want to be careful when you're doing that. You don't want to just like do it every time you can just for fun. Because like it can, like if this were to change, then like you might not want this whole size changing. And so that could like create problems accidentally. Anyway, okay, and then I'm gonna go ahead and circular pattern this again, right? So once again, I click and then I get my preview. I can click to confirm. I'm gonna edit this before I confirm. And then I don't need this dimension, so I'll just go ahead and snap this to the full. I'll click to confirm that, right? It defaults to the origin, but I need to actually constrain it, so I'll drag it off and then make it coincident. And so now we're fully constrained. Cool. So I'll go ahead and confirm this sketch, right? And show it. So then I can go ahead and extrude it, right? And so one thing I'll point out, right, is my sketch actually has 2 faces, right? So if we hide this part, right, you can see visually my sketch should have 1 face here, right? But I actually get 2, right? And the reason for that is because we're actually imprinting on this face because we're sketching on it, right? So if I go back to my sketch, right, you can see here when we selected the sketch, we're sketching on this face. And so that causes the sketch to imprint on it. And so this edge here is actually being used to generate, or is actually splitting our sketch and making it into two separate faces. And so sometimes that behavior is helpful. More often than not, it's not. In this case, it arbitrarily divides our sketch into two regions, which doesn't really make sense. And so the way we can disable that behavior is by using this disable imprinting option. So that's what this disable imprinting option is for. It's for when you're sketching on a face, if you don't want that face to carve itself into your sketch, you can disable that behavior that way. Of course, the other way of doing it is you can just sketch on construction planes, not sketch on faces in the first place, and then you won't have faces to imprint on. But yeah, so go ahead and disable that. If you don't, you can just select both regions, it's perfectly fine. I think you could also just click the region, or click your sketch like that, and then it would grab both regions and it would also work. But that is something to be mindful of. Yeah, and then this is just 0.75 inches. And again, we can see editing logic kicking in, making this add and selecting our merge scope for us, which is convenient. Yeah. Okay, cool. So we'll go ahead and do that, and then we're going to rename this to reducer coupling. Cool. Yeah, and then they say you could optionally try to create a different way by sketching this entire profile at once instead of doing these side profiles and then adding the holes back, which should also be perfectly fine. But yeah, so we'll go ahead and do the self check. Here we can grab our surface area, and then 248.367. And so if we go to do the check, 248.367 is a valid answer, and that is correct. So we did that correctly. So yeah. All right. So now we're going to move right along to the Jackhammer gear cover. So I already copied it. You can copy their document and work inside that. That's perfectly fine. And then we just want to make sure our workspace units are millimeters, and we want our mass default to now be kilograms, which is fine. Okay, so we can see here, yeah, we just have the part studio, and then it also comes with an image. I don't have it right now, but you can look at that. Yeah, so the first thing we're going to do is we're going to shell the bottom. So I'm going to go ahead and grab shell. I can search for it using search tools because I'm not, oh yeah, there it is. And I can grab it here, and you can also see it highlights when I have it hovered. So if you ever need to find something, you can't find it, you can search it up and then do it that way, which is very convenient. And then we'll grab this face to remove, and we'll set our shell thickness to 4 millimeters. Cool. So I'll go ahead and confirm that. Okay, so now we want to go ahead and make a new sketch. So we want to be sketching on this face here, right? I'll go ahead and orient normal. And then we want to have 3 points. So there's going to be one up here, one here-ish, and then one here-ish, right? And then, let's see here. Yeah, so we can see here this distance, this dimension here. So when I dimension, I can, between points, you can have your choice of 3 options, right? So I can get the horizontal, the vertical, and then also the direct inline. So here we want, I'll just grab the horizontal, I'll make that 16. I'll go ahead and make this 93, right? I'll make this here 95 millimeters. And then important, none of these points are vertically in line with each other, so make sure you're not getting an auto constraint of vertically in line, because that would be wrong. But then here, this last two, this distance here is 4 millimeters. Yeah, so now we have a set of points, and we can see they move together. So we just need to figure out how they're constrained to the origin. And so here that we can see they're asking us to make a concentric constraint. And so a concentric constraint just puts something in the center of a circle or arc. So here we're going to put this point in the center of this arc here. And of course that works because we can just use external geometry, like it's in our sketch. There's no requirement. Or you can constrain to stuff that's outside of your sketch. It's not a problem. Yeah, so once we do that, then we can see we're fully constrained. And then we want to put these points on the other side, so we'll go ahead and select them, grab mirror, and then we can just mirror about the right plane. They show drawing on a construction line using that, which is also perfectly fine. But I say, you know, if you don't need a construction line, why add one, right? When we can just use a plane. But yeah, so that works. So we'll go ahead and confirm that. And now we want to go ahead and make a whole feature, right? We can select all of our sketch points manually one by one, or we can click the sketch to get vertices of sketch 10, so it'll select all of them for us automatically all at once, which is convenient. And then we want to change this to counter bore. Clearance, we want this to be M5. Let's see here. Oh yeah, so you have to change this to metric. M5, yep. Close, 5.3, yep, that all gets set automatically. Yeah, so this is like a default hole. And then we want to make sure our merge scope is gear cover, which got set automatically for us thanks to editing logic, so we like that. Start from part through all. Okay, yep, so that's right. So we're going to go ahead and confirm that. But we can see it looks a little goofy because the shell is making it too thin, as they're saying. And so what we can do is if we reorder the shell, right, then that sort of magically fixes it, right? So if we step through the feature tree like this manually, right, so we can see when we shell it, right, so before we had it like this where we shelled, we sketched, then we added our hole, right? And so when we went to add our hole, it was already shelled, so we're just cutting a hole. Whereas when we put the shell last, right, now what we're doing is we're sketching, we're adding our hole, and then we're shelling. And so because we're doing shell last now, we're shelling around the hole. And so that makes it nice for us, which is pretty cool. So this is a good example of like how like the order of features in your feature tree can really affect things, and how you can kind of manipulate it sometimes to get different behaviors. Okay, cool. So now we're going to add a chamfer. So we'll go ahead and do that. And then we just have to click here and here. And then we want our distance to be 2 millimeters, which is correct. Yeah, cool. And they have theirs set to distance and angle with the 45-degree angle, which is kind of goofy because equal distance is 45-degree angles by default, so there's not really a reason to change that. I'm not sure why they have it like that. But yeah, so that's fine. And then okay, now we're gonna go ahead and add a fillet. So that'll go down here. So we'll grab this edge and this edge and this edge. And here, yeah, we're gonna select 1 millimeter. And then we'll point out, by default, tangent propagation is on, right? You can see with it off, it's not grabbing this edge, for example. But, you know, so you can see we're propagating the fillet along tangent connected surfaces or edges, so that saves us a few clicks, which is nice. Cool, we'll go ahead and confirm that. Okay, cool, and now we're gonna add another fillet to the top. And this guy is gonna be 3 millimeters. Right. Once again, tangent propagation makes it easy for us. Yeah. And that looks pretty good. So we'll go ahead and confirm that. And so now if we check our mass of our part, we can see our mass is 0.445 kilograms. So if I go to do the self-check, we can see that's correct. So we did it. Cool. All right, moving right along. So now we're going to move on to the funnel. So I'll go ahead and create a document named funnel. I'll change my length units back to inches and back to pounds. All right, and yep, rename this funnel. Cool. All right, so we're gonna go ahead and create a new sketch on the top plane. Yeah, and so we're gonna go ahead and sketch like this, right? We're gonna make this line like this, and then we can see we didn't get the auto constraint, so I'm gonna do that. Let's see here, yep, okay. And then we're going to add 2 ovals, so I can, or 2 ellipses centered on the origin here. So one like this. And then here, it's very important to use the offset constraint because you can't add the offset. There's no like, so unlike mirror, so like with mirror, right, when you mirror something, all it does is like duplicate the entities and then add the symmetric constraint. When you use offset, there is no offset constraint. So the only way to get an offset constraint is to actually like use the offset tool and like create a new entity that's offset. And so the consequence of that is if it's already been offset, or like if you lose that offset constraint, there's no way to get it back, which is a little unfortunate. So that's just something to be mindful of. And so here I'm going to offset this inwards, I think. Yeah. So I'm going to make this inwards like this. I'm going to make this 0.125 inches. I'm going to go ahead and click to confirm that. So that's an important step. That's easy to mess up. But yeah, so now I'm going to dimension my outer one to be 6 inches and 4 inches. Yep. And then this is going to be 4.5 inches. This is 1.5 inches, right? And then we have that degree of freedom, so I can probably get rid of it using like a midpoint constraint is one way of doing it. You could also do like a symmetric on these 2 points and this line, right? So that way it's symmetric, same difference, right? And then we have a line here, not construction mode, and a line here, right? And this is going to be tangent. And I'm going to go ahead and make this, I guess I'll just add the tangent. But you could also make them symmetric about the origin, or about the front plane, and that would also be perfectly valid. Okay, so we're fully constrained, so I'll go ahead and confirm that. Cool. So now we're going to go ahead and extrude this, so I'll just grab my face, and this is going to have a depth of 0.125, and we can see it's going to be facing up, which is the default. So we're happy with that. Cool. Okay, so now we need to go ahead and sketch another sketch on the top plane, right? And so here I'm going to hide this just so I have a little bit better view. And so this part's a little confusing. The offset is is outwards, right? So I'm going to go ahead and offset this. I could also offset like the edge, right? But I'm going to use the sketch because that's a little bit more robust because like the part might get deleted, but the sketch will probably stick around. And so yeah, so it's important to realize that this is going this way. So it's going back towards the lip, right? A lot of people think it's going inwards, which is wrong. Their picture isn't very clear, but it is like this. So make sure you have it facing the right way. Otherwise you will be sad. Yeah, so I'll go ahead and confirm that. Cool. Great. So now we're going to go ahead and create a construction plane. And that's going to be down 3 inches. All right, make sure you face that the right way. And then we're going to do a mid-plane. So here I can take advantage of editing logic again. So if I pre-select these planes, right, when I click it, Onshape, we'll see that I have 2 planes selected. And so it'll change to mid-plane automatically. Otherwise you can just, change it to mid-plane and then select your 2 planes, and that also works. But you can see here we're grabbing, it's giving us the middle of these 2 planes, which is convenient. And I'll go ahead and rename these features, I guess. Which is generally a good thing to do. Generally, I say like anything in your top level feature should be named, especially as things get more complicated. It just helps make things more organized and easier to understand. Okay, so now we're going to go ahead and sketch on our middle plane, this profile here. So I'm going to hide that sketch, and we just want a circle. And it's just going to be out like this, right? 2.5, and it is this way, a 1/2 inch. 5. Yep, that looks right. Gonna confirm that. Okay, and then we're gonna go down to our lower profile and rinse and repeat. Make you horizontally in line with the origin. 0.75. I'm going to write normal so you can see what I'm doing. Sketching in 3D can be a little funky. But yeah, you can see what that looks like. So that looks right. Yeah, and now we can go ahead and create a loft. So I'll grab my loft tool like this. You can see it's over here. Yeah, and so we're going to be lofting between this profile, right? This profile and this profile. So you can see that there. And then I had this part hidden, so it didn't change to add automatically, but I can do that and just change to add, and then editing logic fills in the merge scope for me, which is nice. Yeah, and then everything else should be fine. I guess this is going to start normal to profile, and it's going to end normal to profile as well, and the start magnitude is going to be 0.5. Yeah, cool. All right. So then here, they ask us to make a shell and select this face and this face, right? And set the shell thickness to 0.05. And then they point out that this fails because it's trying to shell the handle here, I guess, which doesn't work. So you can see like the error geometry there. But yeah, so then what they have you do to fix it is go back to the loft and instead change this to a new loft, right? And then if we use the final button, we can see our shell is now happy. So yeah, so we sketch, we loft, we shell the loft, and then we add it back instead of adding it to the feature and then trying to shell it. So once again, taking advantage of the feature tree order. And then, so now we're going to have to manually Boolean it. I'll point out the Boolean, right? So like these options inside like an extrude or like a loft or a revolve, new add, remove, and intersect, right? These are literally just Boolean operations that are stapled onto the feature, right? So like an extrude that's an add extrude is equivalent to creating a new extrude, right? And then going back and then doing a Boolean union between whatever you just extruded and whatever your merge scope is, right? So this is just like the manual version of doing it inline. So in cases like this where like the inline version doesn't work because we need to do something else before we Boolean, we can do it explicitly using a Boolean feature manually, and that's perfectly fine. Yeah, so you can see this looks pretty good now. And one other thing I'll point out is the order of selection in a Boolean. By default, the first thing you select is what's gonna keep its identity. So here, for example, if I click this gray part first, right, you can see we get a gray funnel, whereas if I select this blue part, then we get a blue funnel. And so that can sometimes matter for like robustness, and like if you've like already set one or like named one, then the order of selection might affect which one you keep and which one you yeah, so sometimes that matters. Just something to be mindful of. Okay, cool, and then we're supposed to fillet this, and I'm noticing here this is a smooth connection, which they don't have, so I think I did something wrong, so I'm going to go back and check my sketch. Yep, I sure did. So I made the mistake of making these tangent here, so I'll fix that. So if I show constraints, I can see the tangents here that I'm not supposed to have. Instead, this is supposed to be 105 degrees, so oopsies. And then instead of adding dimension twice, I'll just go ahead and make these symmetric about the right plane, or the front plane. Yeah, so that works. Okay, yeah, so hopefully that didn't confuse anybody. But yeah, so now we can go ahead and add our fillet in. So I'll just grab these 4 edges. Our fillet radius is really big for some reason, but I can change this to 0.5, and now it's nice and happy. Cool. Yep, so we'll go ahead and confirm that. And now they want us to draw a little profile here. So I grab the front plane, right, I'll ring it normal. So I guess we need this shown. But basically it's just going to be a little guy like this, right? It's going to come up right? And so here there's, it's easy to grab like auto constraints here, so you just want to be mindful. Like here it's trying to make it perpendicular to that line, which is kind of goofy. So instead I'm just going to make it vertical. I don't really need to be referencing this line, you know, there's not really any point, even though it is technically correct. And then I'm going to make a 3-point arc like this, right? So I can grab like the tangent there, that's fine. I'll make this tangent as well, right? So I have this profile. And then here, right, so they're making this center point here using the pierce constraint, right? So grabbing, you know, where this line here pierces our sketch. Another way of doing it, right, is you could coincident to like this point, for example, right? So that would give us, you know, make this point coincident with that point. And I think you could even coincident with the line here. No, because it's perpendicular. But yeah, normally coincident tries to like project it onto it, but because it's passing through or like perpendicular to our sketch, you have to use the pierce constraint here, unless you're like coinciding to like a point which it can just project. But obviously it's a little strange, perhaps. But yeah, so we can grab that. Down here, let's see what other degrees of freedom we have. This can move like this. To fix that, I'll just make this in line with the origin, probably. It's probably easiest. And then we have this degree of freedom. So I bet if I set this radius, now we're fully constrained. So there's a couple different ways to constrain this. That's just how I chose. But yeah, so that's right. So we'll confirm that. And now we're going to sweep this. So sweep, I'll grab my sketch. And then I have to select my sweep path, right? And so the easiest way to do this is to just manually, or like, you know, like one way to do is just like manually click all these edges one by one. That's a fair amount of work. So one alternative we can do to speed that up is we can right click and we can actually choose, if we go down to select, one of these options here is tangent connected edges, right? So this will give us, oops. So if I right click this, I click select, I select tangent connected edges, it'll give me all of them automatically, right? You can also do it explicitly through the create selection dialog. So if I create selection, I can like select an edge, and this gives me a preview so you can see what it's doing. But you can see like I can also do like a you know, tangent connected. I can grab like all the equal edges, which would give me like that one because that's equal, or like parallel edges, same thing because that's parallel. Obviously here tangent makes the most sense, but you know, once I have like you know what I want, I can just go ahead and click like add selection and I'll just add it to my dialog like that. Yeah, so it's a little bit faster perhaps than clicking them all manually, one by one. But yeah, cool, so that looks good. And then once again, I'll point out Onshape did change it to add and set our merge scope for us automatically, so you can see editing logic hard at work. Cool. And then now we'll go ahead and create extrude. Once again, Onshape changes to add, sets our merge scope, and we just want to make sure this length is 1, which is correct. Yeah. And I think Onshape will also set the direction too. So you're not like, because obviously like this here would be they're like self-intersecting. So editing logic does actually do quite a lot of work when it's not being annoying. But yeah. All right, cool. And then we're going to set the material. So we'll go down here to the part, assign material. They want us to do polypropylene. Yep, and we're supposed to rename it to funnel. Yep. And now we can click our part and click down here to view mass properties, and we can see the mass is 0.098 pounds. And so if we go to our self-check, we can see that that is in fact correct. Cool. All right, so now we're gonna do the last exercise, which is the reflector. Once again, I've already copied it, but you should be looking at something similar to this. Want to make sure our units are millimeters again. And we're back to kilograms. So we're just switching back and forth, which is fine. And of course, if you're copying the document, then it should be set automatically already. But yeah. Okay. So we can see there's already been some work done. We have a sketch and a mate connector here. Yeah, so the first thing we're going to want to do is we're going to want to go ahead and extrude these two faces. And then we're going to set this to a remove extrude, right? We can see Onshape tried to change it to add, but we want to remove in this case. And then we want to be up to face. So this is an easy step to miss, but we're actually extruding up to face here. And the reason why is because this face is curved. So now if we add a offset distance, and we say up to face but back 10 millimeters, right? You can see we're actually, yeah, we're like offsetting from this curved face now, which is cool. But that's how you can do that. And then they have merged with all set, which is fine. Doesn't really matter. Either one works, because obviously we only have one part here. But yeah, so we like that. Cool. All right. And so then we're gonna fill out the pocket. And so let's see here. I'll hide the sketch just so I can see the pocket a little bit easier. I think there is actually a fancy mode we can do. One thing you can do is like you can click this face, like get all the edges on it automatically. That doesn't work for like up here though, because it'll grab those, which we don't want. I think we can also get fancy and not this edge. I think we can once again go ahead and try to make a selection. And I bet we could do, let's see here. So I wonder if we could do, I guess we could do like equal length edges. Oh, no, they're all different. That's sad. Really? Are they not? No, I guess they're not. Okay. Yeah, maybe we could do like pocket faces? No, that gets all of those. Yeah, well, I guess you could do it like this, and then you could, oh, you can't manually deselect. Oh, it's so sad. Okay, we'll clear this. All right, yeah, so probably the easiest thing, the fastest thing to do is just like the two bottom faces, and then you can grab these edges manually. So that's perfectly fine. Yeah. Okay, cool. So you can see we have like that. So you just want to make sure you're getting all those edges. And so it looks like that. Cool. Oh, and then that is going to be a 6 millimeter fillet. So make sure you remember to change the radius. Cool. All right. So now we're going to go ahead and do a feature pattern, right? So we already saw like a sketch level pattern earlier, right? Here we're doing a feature level pattern. And so the benefit, of course, is, yeah, so we're going to grab our circular pattern. Right, so by default, it's part pattern, which will pattern entire parts. Here we can change it to feature pattern. And so this allows us to copy features. So here we're going to pattern our extrude and our fillet. And then our axis, we're going to choose our pattern axis, which is just like kind of the origin basically. And then, yeah, by default it's 360 and we get 4 instances, right? So here you can see like, you know, if we were to try to do this with like a sketch pattern, right? We would have to like manually select and like manually fillet all 8 of these pockets instead of just like 2 and then patterning the fillet as well. So you can see the benefit of pulling out to the feature level instead of just like trying to do it in the sketch. Yeah, and then we can choose here like the face pattern is working, but we do want to reapply features. So that way it like recomputes the offset each time instead of just like copying the exact geometry. Well, I think in this case, copying the exact geometry is fine, but actually, yeah, because this is rotation asymmetric. But if this is like some crazy pattern, then reapply features would get it to update correctly. Yeah, cool. So we like that. So we'll go ahead and confirm. Now we're going to go ahead and add a hole. So once again, we'll use our pattern axis. It's going to be a metric, simple hole, and the size is going to be M45. It's going to be close, and it's going to be a blind hole. It's going to end 12 meters down, and yeah. So just be careful, it's not actually a through-all hole, it's only 12 millimeters in depth, which is an easy mistake to make. And then Onshape selects our merge scope automatically, so you don't have to. But if it doesn't, then you can do it yourself. Okay, cool. So now we want to sketch on the top face. You could also sketch, oh yeah, I guess we can just sketch on the top face, that's fine. We're going to add a point here, it's vertically in line. And this is going to be 26 millimeters from like this face, for example, which is fine. Yep, so that's fully constrained. Okay, cool. And then we're going to go ahead and create a tap tool, which is going to be an M10. Oh, it's tapped. Okay, tapped. Yep. So a tap tool just has like threads cut in it. Most 3D CAD software doesn't actually model the thread, just because it's a lot of work and like, yeah, it's just really performance intensive and it's not really that important. But the difference between setting it like clearance or tapped, when you get like the standard hole sizes, because when you tap a hole, you need to drill the hole a little bit smaller so you can like still have room to cut the threads. But then the other thing is, when you make like an engineering drawing of this part, it'll have all the information set correctly. So it'll like call it out as like a tapped hole, rather than just like being a regular hole. It's just like, you know, a diameter. That's also the difference between like using the hole tool and like using just like sketching and extruding a circle, is you do get some hole information. And like if you're doing like a tapped hole, you can't do that with, you know, just extruding a circle. I mean, you can, but like when you go to make the drawing, you'll be sad. So yeah. Anyway, so our pitch is 1.5. Yep, simple metric. And then our termination is 20 millimeters depth. Tapped, straight tap, M10 pitch. Oh, fastener fit is going to be none. Okay, cool. Yeah, and then these defaults are fine. And they have this turned up to 6.653. Am I missing something? Oh, I probably am. Termination blind, 8.5, fastener fit none. Okay. I don't know, they have these as set as different. I'm not sure if they just like, I'm not exactly sure what that's all about actually. But it doesn't really matter. It's kind of arbitrary because we're, you know, but yeah, I'll just change that, I guess, for posterity. I wouldn't worry too much about that. It doesn't actually affect it doesn't affect your model in any way. It's just for the drawing. Okay, so now we can go ahead and linear pattern this. So we'll grab our linear pattern. Once again, we'll change it to feature pattern, or actually face pattern. Face pattern and feature pattern are actually kind of similar. Feature pattern just, by default, feature pattern will just grab all the faces of something, of what the feature created, which is equivalent to face pattern. Although feature pattern does allow you to reapply features, which sometimes matters. You know, like with the extrude up to example we were talking about earlier, where it could make a difference. But here we just need the whole faces, so you know it doesn't matter. For direction, there's lots of different ways to specify directions. I like selecting a plane, which will give us the direction normal to it. So it'll be like this way if I select the front plane. You could also like select like an edge, for example, and it would, you know, give you the direction of the edge. But I think the plane is probably the most robust way of doing it for here. Flip that around, say 26 millimeters, and then we have an instance count of 6, right? And then we're going to skip our 2 center holes. So we'll just go ahead and click those in the graphics window like that. Yeah, so we just have that. Cool. Yep, and then we're going to go ahead and extrude this cutout guy here to a depth of 11 millimeters. And here we can see Onshape try to change it to add automatically, but we need it to be remove. So we'll go ahead and change that. And then they have merge with all selected for no particular reason, but that's fine. Yeah, and so, yep. Yeah, so that's good, and then we're going to fillet this guy as well. So I'll hide this sketch, and I can select this face, and then I can select these guys as well. Don't forget to select those guys. Oh, actually I don't have to. Yeah, so I can just click the bottom face and it'll grab all those edges, so it'll just be like that, which is good, and this is going to be a 6mm fillet, which we already have set. Cool, so we'll go ahead and set that. And then we're going to mirror this guy. So we'll do mirror. Here you could do a feature mirror and just select your fillet and your extrude. That would work perfectly fine. I can actually show that. So you just mirror like this. They're having you select the faces manually, which is fine too. So you could click all the faces. Obviously that's a lot of clicks. So they're showing right clicking, and then you can select pockets directly is like an option. But they're showing the entire manual flow. So like I was showing earlier, you can create selection to bring up this dialog. You can change to like pocket or like hole, and I can grab like this, and then you can see it's giving me my pocket faces, so I can go ahead and add that. So, you know, a bunch of different ways to do the same thing. But yeah, so any of those ways are perfectly valid. And then we'll go ahead and confirm that. Cool. And so now we can go ahead and measure this guy, and our mass is 2.037. So if you do the self-check, we can see that's an answer, and that is correct. Yeah, so that is Introduction to Part Studios. Hopefully that makes sense, and is not too bad for you. Thanks. Talk to you guys later.